The next concept we want to look at in section 1.4 is the addition and subtraction of rational expressions. So the key here is coming up with the LCD, the least common denominator. All right, so for example, well, I should state if you have a common denominator, then you just write whatever you end up with on the top over that common denominator, and then you're going to combine like terms if possible. Okay, I will go over how to come up with that LCD by way of example here in just a moment. The only other thing is with subtraction, you're just going to add the opposite. Okay, definition of subtraction. Again, I'll go over that as well by way of example. Okay. This is something you should know if you understand the theory here in terms of LCD. But again, I like to explain everything by way of example. Okay, I'm not just going to give you notes like this and say good luck. All right, I'm always going to give you a few examples to help you understand the concepts, the theory that is being presented. Okay, but this is basically the process. You're going to find the prime factors, the denominator, and then you're going to use what? What actually makes up the LCD? Well, it's the product of what? All of the prime factors. So what does that mean? Well, you're going to use the highest power of each prime factor that appears in the denominators. Okay? So in other words, if you had, for example, like 2 over x minus 1 plus 4x over x minus 1 quantity squared, for example, these are both prime factors, okay? The LCD would be the one of highest power. So the LCD would be this x minus 1 squared, all right? And then, you're missing another x minus 1 here, so you'd have to include that in the numerator. So you'd actually get this. See how we're missing one x minus 1 in this first expression? So that means we have to add an x minus 1 to both the bottom and the top. And so I'm showing you that right here. I've added an x minus 1 in the numerator position of this fraction. And then I'm going to add just a 4x because 4x is already over the quantity of x minus 1 squared. And then if you wanted to, you should distribute the 2 through and then combine like terms. But again, I'll show you more examples as we go through the notes. All right, so let's look at these two. Number one, first thing is to come up with the LCD. So in this case, there's really nothing to factor or possibly reduce initially. So the only thing we can do is just look at both of these denominators and notice they are different. So because they're different, and that's all that is existing, that has to make up the LCD. So our LCD in this case is just going to be the product of, oops, not plus, geez. Okay, 2x minus 1, right? So the LCD here is just, again, the product of what? The highest power of our prime linear factors, okay? So since these are different and they're both understood to be raised to the first power, the product of those two factors is equal to our LCD. Now, what do we do at this point? Here's what I recommend. Some of you were probably taught this in one way or another, but here's what I suggest. This historically has helped more students than not, okay? So I'm going to write down the given numerator in my first fraction. I'm going to recognize that it is over 2x plus 3. All right. Because it's already over 2x plus 3, we don't need to do anything with this, but what are we missing? We're missing the 2x minus 1. So whatever part you're missing in the first fraction here, that's what you're going to put up in the numerator position to be multiplied by the given numerator. In this case, the given numerator is 2. We're missing a 2x minus 1, so we put that right next to the 2. Then we bring down the plus. And then we do the same thing for the next expression. So we're going to bring down the 3, and we're going to think, okay, it's already over the 2x minus 1. So what are we missing here? Well, we're missing the 2x plus 3. So we put that next. And so now, at this point, what do we do? Well, all we have to do now is distribute here and distribute here to actually simplify this thing. So what do we get? We get 4x minus 2 plus 6x plus 9 all over the same LCD, quantity 2x plus 3 times quantity of 2x minus 1. And then at this point, you can just leave the LCD the same. In other words, you don't have to multiply these two together. You can if you want to, but this is fine. I'll accept this. And so we'll have a sign. But we do need to combine like terms on top. So 4x plus 6x, 10x, minus 2 plus 9 is plus 7. And we're finished with the first example. Okay, example number 2. Same idea. If you're adding or subtracting rational expressions, you have to come up with the LCD, the least common denominator. Just like if you were to subtract two numerical fractions, all right, without a calculator, of course, you would come up with the common denominator and then add the two numerators together over that common denominator. It's the same idea. It's just this is more challenging because there are variables involved. All right, so the first move is to factor if possible. And so it is possible in this case to factor. So let's go ahead and do that. Let's factor everything that is able to be factored. That's what you always want to try to do first here. So what do we get? We get this, x minus 1, x plus 2 for this first trinomial. And then for the next one, we get what? It has to be a 2x there and an x there. And let's see, would this be a 1 and a 2? And would this be a plus and a minus? Well, let's check. Inside's negative 1. Outside is positive 4. Does negative 1 plus 4 give you a plus 3? It does. And again, the first part gives you a 2x squared. Last part gives you minus 2. So we're in good shape. All right, so after you've successfully factored everything that's able to be factored, you then look to see if you can reduce just within each respective rational expression. So there's nothing to reduce there. However, in our second rational expression, note there is something that repeats. You have a 2x minus 1 on both the top and the bottom. So let's go ahead and cancel them out, leaving you with just a 1 on top there. Actually going to make this one much nicer, isn't it? Okay, so LCD time. The least common denominator is going to consist of what? All the prime factors of highest power. So we have an x minus 1, and we have an x plus 2 here in the first one, and we also have an x plus 2 in the second one. Well, they are both understood to be raised to the first power, so that is the highest power of this prime factor. So that means that just x plus 2, that quantity, is also a part of our LCD. Okay, so at this time, we're going to do the same thing we did in example number 1. We're going to decide, okay, what's missing, if anything, in the numerator. So look at the first expression. We have an x in the numerator all over this. Well, we already have this all over our LCD, x minus 1, x plus 2. So there's nothing more we need to do with this x. So what we do need to do next is bring down the minus. And then what do we have? Minus, bring down this numerator of 1. I'm going to go ahead and put a 1 there. And then in this expression, are we missing anything? Yeah, we are. Look, in this denominator, we only have an x plus 2. But the LCD is x minus 1 times x plus 2. So we have the x plus 2 taken care of, but what are we missing? We're missing the x minus 1. So whatever you're missing, you put that in the numerator position next to the given numerator. Okay? All right, so at this point, we just simplify the numerator, and then we're all finished. So what do we get? Let's add the opposite, right? So when we add the opposite, we do what? Or you could just distribute the negative 1. It doesn't matter to me. But definition of subtraction is add the opposite. Either way, you're going to get this. You're going to get x minus x plus 1 all over this, which gives us the following. X minus x, gone, and then plus 1. So there you go. You get 1 all over the quantity of x minus 1 times the quantity of x plus 2.